On 4-7, you're like, dude, I've seen these problems before, and you have. But this dude named L'Hopital, literally, that's how we say it, and sometimes you might see this with or without an S, okay? Either spelling goes. This was his last name. So like Roro said, you're like, well, when I plugged in a 2 here, I'd get 6 minus 6 over 4 minus 4, so I'd get 0 over 0. And we've seen that before. And what we had to do before, does anyone remember? We had to factor this. We had to factor it. So we can, let's just remind ourselves, if we factor that top, what does that top factor into? Say that again, bud. I'm sorry, I can't hear you. Well, we got to multiply to be negative 6. Right? X plus 3, x minus 2. What about the bottom? That's a little difference of squares. X plus 2, x minus 2. Does anything cancel? My x minus 2's. And then we can just plug my limit back into what's left. So what would my answer be here when I plug a 2 back in there? 5/4, right? And that's my answer. And we can do it that way. But Mr. L'Hopital, as things get a little bit more difficult, if they aren't quite factorable, he's like, okay, that's fine. That's totally fine. We can do it that way. Or once we got 0 over 0, what did he say? He said, just take the derivative of the top and the derivative of the bottom. So let's try that. Let's do that here. What's the derivative of the top going to be?
2x plus 1.
Appreciate you. Derivative of the bottom, no quotient rule needed. 2x. Now when I plug in that 2, what are we going to get now? 5/4. We get the same thing. So again, either way works. This is just going to be easier when in times that we like don't know how to factor and stuff. So anytime you plug in that 2 and you get a 0 over 0 or an infinity over infinity, just take the derivative of the top and the derivative of the bottom, keep plugging it in until we get a value. So that's what I wrote right here. This L'Hopital's rule. If when we plug in that value, that C value, and we get, it's called an indeterminate form, 0 over 0 or infinity over infinity, then just take the derivative of each of them, and we're done. So when I plug in a 0 here, if I plug in a 0 right here, what would I have on top? 1 minus the cosine of 0. What is the cosine at 0? 1, right? So that'd be 1 minus 1 over 0. Do you agree we're getting an indeterminate form when I plug in that 1? I'm sorry, when I plug in that 0. And before, so like we couldn't factor this or things. It'd be hard if as soon as you get that 0 over 0, we just go ahead and apply that L'Hopital's rule. And we got to just take the derivative of the top and the derivative of the bottom. What do we want to say the derivative of 1 is? Good, 0. The derivative of negative cosine. Sine of my angle times 2. Good job, chain rule. Over 5. Once you have taken that derivative, then we just plug it in again. And we see what we get. What is the sine at 0? 0 times 2? Over 5? What is anything? Yeah. So this one is not indeterminate form because 0 divided by any number is 0. It's when we get a 0 divided by 0 that we'd have to keep going. But you can get a limit of 0. And if I were to look at this on a graph, it's fine to have an answer of 0, just not 0 over 0. Let's try another one. Should you apply L'Hopital's to the following 4 functions? So it's saying you only apply L'Hopital's when we get a 0 over 0 or an infinity over infinity. What's the sign of 0 here? 0 over, what would we have here? Negative 1. What would my answer be there? It's just 0, and it'd be no. We wouldn't apply L'Hopital's rule. We're done on that one. Let's skip this guy. How about this one? What do we have up top? Sine of 0, which is 0, over? Yeah, so because we got an indeterminate form, we are going to apply L'Hopital's. And how does that look again? Derivative of the top over the derivative of the bottom. What is the derivative of sine? Leave the angle. Derivative of the angle? 1. Good, so we're done with that. Derivative of the bottom? 2x. When I evaluate my limit now, what's the cosine at 0? 1 over 4. Done. We like L'Hopital's. L'Hopital's is a shortcut for us. How about this one? We applying L'Hopital's here? What's ln of 1? Does anyone remember that? You're thinking of derivative. What is just ln of 1 is going to be 0. What about 1 squared minus 1? Yeah, so we are going to apply L'Hopital's here. And then, to your point, Ev, now we are going to apply L'Hopital's, so we do need the derivative of natural log of x. Whoo, haven't seen that in a bit. Derivative of natural log? 1 over x over 2x. Go plug in that 1. Final answer? Yeah. This is kind of a cool way to look at it. The table gives us some values, and they said, hey, what's the limit of this function? You're like, okay, first things first, we always just plug in that 3. What happens when I plug in that 3? Wouldn't that be f of 5 on top over 0? If I plugged in a 3 here? Okay. Did they give us what f of 5 was? Of course it is, right? F of 5 is 0. So do you agree we got 0 over 0, and we'd have to go L'Hopital's it? Eh? Okay. So we're going to say, all right, what's the limit as x approaches 3? What would be the derivative of the top one? Be careful. What's that? Outer. Derivative of the outer. F prime. What do we do with the inner? Leave it. Keep it. Love it. Times the derivative of the inner. 2. All over the derivative of the bottom one. 2x. Okay. Plug it in again. We'd have f prime of how much? F prime of 5. Then we'll multiply that by 2, and then we'll have that all over 6. Does that seem right? Do we know what f prime of 5 is? 7 times that 2 over 6. Final answer? (14/6), which is the same as 7/3. On this guy, what happens when I take infinity and I cube it? Wouldn't it still be infinity? Infinity times infinity times infinity. It's going to get me infinity. What about e to the 3 times infinity? Just to remind you, the graph of e looks like this. Whoosh. And as I'm going e to the infinity, what's going to go to that value? What's that value going to go to? Infinity. So this gives me that infinity over infinity. And because it does, we're going to apply L'Hopital's. Okay? And that L'Hopital's, again, is just go take the derivative of the top. What would the derivative of the top be? 3x squared. What about the bottom? Derivative of e to the anything is e to the anything times that 3, the derivative of the exponent, right? So I'm going to throw that out front. What happens when I plug that infinity in again? I'm still going to have infinity on top. What about on the bottom? I'm still going to have infinity again. So this is where L'Hopital's comes in. He's like, cool, cool. It's NBD. Oh, you got infinity over infinity again or 0 over 0 again? You just do it again. We just apply L'Hopital's again, which means take the derivative of the top again and the derivative of the bottom again. Derivative of the top is going to turn into 6x. Derivative of the bottom.
9.
Yes.
E to the 3x.
Beautiful. Because you're saying the derivative of 3e to the 3x is 3e to the 3x times the derivative of that 3x gets me another 3. I like that you wrote that as a 9 instead of a 3 times 3. So I love that. Evan, way to come back strong after that turkey break. Throwing in an infinity on top, what am I going to get? Over? Okay. I promise we don't have to do this forever. You are going to get an answer eventually. Let's try one last time. Derivative of the top. 6, derivative of the bottom. Right, derivative of 9e to the 3x is still 9e to the 3x times the 3. Final answer, 27e to the 3x. Interesting. So now you guys, when I plug in infinity, bless you, here, I've got 6 divided infinitely many times. Whenever you've got just an infinity on the bottom, boom, we're at 0. Whew. You guys, again, couple different ways we could look at this thing. This is that formal definition of the derivative. Woof, we've seen that before. But we can always go L'Hopital's with these limits now. If I put in a 0 right here, wouldn't I have ln of 4 minus ln of 4 over 0? Wouldn't I have a 0 over 0 again? So what's the derivative of that top? Derivative of natural log of 4 plus h is going to be 1 over 4 plus h times the derivative of 4 plus h would just be a 1 minus the derivative of natural log of 4, 1 over 4 times the derivative of 4, 0. So this thing actually doesn't exist because natural log of 4 is actually just a constant. This is a value, okay? Why is it different over here? The derivative of 4 plus h would be, so we'd multiply this by 0 plus 1. So we'd be multiplying this by 1, so that's why this guy stays alive. Derivative of h on the bottom, great. Let's go plug in that 0. Final answer? Okay, let's try this guy. If I'm going to infinity, you guys, infinity cubed, minus some infinities, plus some infinities, minus 4. What do you think we'd have on top? It's going to be an infinity. She said, I'm going to guess infinity over infinity based on this lesson. You are not wrong, girl. Infinity cubed minus some infinities plus some infinities minus 1. It's still going to be infinity. Okay. That L'Hopital says, go take the derivative of the top. Derivative of the top is getting me anybody? Thanks. Yeah. Derivative of the bottom? You saved me. I was going to say 12x cubed, sir. Guys, what do you think is going to happen when I take infinity and I square it minus some infinities plus 3 over, yeah, we're still at infinity over infinity. What about that derivative again?
6x minus 4 over 24x minus 6.
You know it. In 6 infinities minus 4 over 24 infinities minus 6, still going to be leaving me with infinity over infinity. We're almost there, people. We are almost there. Limit as x approaches infinity. We just keep doing it till we get an actual value. Derivative of the top. Derivative of the bottom. Hey, what happens when you plug in infinity there? 26 24ths is just a fourth. Love. This next one's tricky, I think. It's from 1997, so I don't know if they do one tricky like this again. Back in the day they did. But you guys, what happens when you plug in a 1 right now? What do we get on top? What's the ln of 1 in the bottom? 0. That is not an indeterminate form. Very good. He's saying that's not indeterminate, so I wouldn't apply L'Hopital's rule. Whenever I divide by 0, it's undefined. There just is no limit here. Well said, Ro. On this last one. Ooh. Ooh. If we're dividing by infinity and we got the natural log graph looks like this. Ooh. Natural log graph looks like this. As we go to infinity, that y value is going to infinity. When I plug in that infinity, I'm getting infinity over infinity. What about the derivative of this guy? L'Hopital says take the derivative of the top. What's this going to be? 1 over e to the 3x plus 1 times what? Yeah, I hear it. The derivative of e to the 3x is going to be e to the 3x times 3. Oh, wait, I'm sorry. So let's see. The derivative of this natural log is 1 over this quantity times the derivative of this quantity. Yeah, plus 1. My bad. Boop. Derivative. Why did I? That's why I wrote it wrong down here. That's what threw me off. Boop. Like that. Right? Okay. So here I've got 3e to the 3x plus 1 over e to the 3x plus x. Right? When I just simplified that a smidgy. All over. Oh, my bad. You're right. I forgot the derivative of the bottom. So we took the derivative of the top. I got so preoccupied by that. What's the derivative of the bottom? 1. So it'd be over a 1. My bad. Thanks, Key. What happens when I plug in an infinity here? E infinitely? Divided by E infinitely? We still have infinities over infinities. So let's try this one more time. The derivative of e to the 3x plus 1. What do you think? E to the 3x, limit of, 3e to the 3x is going to be, yeah, Beck?
Isn't it just, if it's infinity over 1, what's that mean?
Good call. So just like Ryan Tucker's going to turn 18 this weekend or this Friday, 18 over 1 is still just 18. So this infinity over 1 is still just infinity over infinity. Yeah, putting anything over 1 won't change it at all. Good question. So we still have that infinity over infinity. What's the derivative of this top guy? 9 e to the 3x. Bottom one? 3 e to the 3x plus 1. Am I still going to get infinity over infinity? Yeah. So one more time.
Can you just do 3 over 1?
3 over 1.
That's out. Not e to the 3.
Oh, not because of the stupid addition here. Because we're adding 1. Now, we're going to get there. To your point, check out this next step. What's the derivative of the top now? 27. E to the 3x. What's the derivative of the bottom one? 9 e to the 3x, because now the 1 is gone, Ev. Now we're saying, oh, my e to the 3x's can cancel out. What am I left with? 27 over 9, which is 3.